the exact value of cosine of something plus another is a cosine of this will be an angle, by the way. So something like, I don't know, maybe let's say alpha. Tangent inverse of 4/3 will be some angle alpha, and cosine inverse of 12/13 will be on the angle beta. Then we have cosine alpha plus beta, and we know cosine alpha plus beta from the formula cosine alpha cosine beta minus sine alpha sine beta. Okay, look at the formula list, it's there. But we don't have to exactly determine alpha, we need to determine cosine alpha though. Same thing here, we don't need to determine b angle beta, which will be a decimal angle, maybe, don't know. But we only need cosine beta and sine beta. So in any case, we have to draw triangles for angle alpha and for angle beta. Okay, so let's assume this is alpha, right? So tangent inverse of 4/3, we are saying that's angle alpha. That is same as tangent of alpha is 4/3. Now based on this tangent alpha, which is tangent is what? SOHCAHTOA. Tangent is opposite over adjacent. So opposite over adjacent, we have a triangle in first quadrant because tangent is positive here. So first just draw an angle and make a right triangle. So this is adjacent, let's say x, opposite, this is alpha, opposite y, and hypotenuse r. So this is now then y over x. So y is 4, x is 3. Okay, tangent is opposite over opposite over adjacent, OA. Now we can find the value of r. X squared plus y squared equals r squared. So 3 squared plus 4 squared equals r squared. That's 25 equals r squared. So r is plus minus 5, but this radial distance is always positive 5. Now we can find any trig function of alpha. Now we do the same thing. Let the second angle cosine inverse of 12/13, let's say this is beta. That is same as cosine beta equals 12/3. Now we can draw a right triangle based on this angle beta. Okay, again plus means first quadrant. Okay, we have another here with beta, and cosine is SOHCAHTOA, adjacent over hypotenuse. So this is x, y, r. So x over r. So x is 12 and r is 13. Okay, this is 12/13, x over r. Y is missing. Now we can use same Pythagorean identity, x squared plus y squared equals r squared, and determine the value of y. So x is 12 squared, 144, y unknown, r 13 squared, 13 times 13, 169. Subtract 144 from both sides, 25. So y take square root 5, plus minus, but everything is in first quadrant. Now we have all three sides for this right triangle with angle beta as well. Now this question is, the given question is cosine alpha plus beta, because we said alpha for the first and beta for the second. And from the formula list, if you look at the here, cosine alpha plus beta is not simply cosine alpha plus cosine beta. No, not that easy. It's by the formula cosine alpha cosine beta minus sine alpha sine beta. Okay, cosine alpha, we look at this triangle, cosine is x over r. X is 3, r is 5, so 3 over 5 times cosine beta here in second triangle, x over r again, but x is 12 and r is 13. In fact, cosine beta was given here, 12 over 13, minus sine alpha y over r, that's the 4 over 5, sine beta y over r, but in this part y is 5, r is 13. We can cancel here 5, but since the bottoms will be the same, I'm not going to cancel here. So if we multiply 2 times 12, 36 over 13 times 5, 65 minus 20 times 65. So we have common denominator of 65, 36 minus 20, 16. Are there any common factors? Looks like none. So 16 over 65 is the final answer. Okay, 16 over 65.